back to my channel. In today's video, we will be going over the most common types of graphs used within statistics. Alright, let's jump in. First, let's begin by going over a few notes on frequency. Frequency distribution is an organized tabulation of the number of individuals that fall into each category on the scale of measurement. Class is a category or value in the data. Class frequency represents the number of observations that fall into a given class. Proportion is the fraction of the total group that is associated with each score. The equation for proportion is the frequency of the score divided by the total number of observations. Percentage is the percent of the total group that is associated with each score. The equation for percentage is the proportion multiplied by 100. Graphs can tell us different things about a set of data. Some of the features of a distribution we can describe from a graph include the number of peaks a graph has, the skewness of the data, and the amount of kurtosis. We can describe the number of peaks a distribution has using unimodal, bimodal, or multimodal. As you can see from the graphs, unimodal means there is one peak, bimodal has two, and multimodal has multiple. Skewness of data can be either positive or negative. Positively skewed data contains outliers at the upper end of the distribution, whereas negatively skewed data contains outliers at the tail end of the distribution. When describing kurtosis of a distribution, we have three classifications: mesokurtic, leptokurtic, and platykurtic. Mesokurtic resembles a bell curve. Leptokurtic is fairly steep around the middle because there is not enough relative frequency in the tails, and platykurtic is more spread out or flat because there is too much relative frequency in the tails. The golden graph, as I like to refer to it as, is the normal distribution curve. The normal distribution curve is also known as the bell curve, and it is unimodal, symmetric, and mesokurtic. Ideally, this is how we want our data to look like. Okay, now that we have covered some basics, let's look at some graphs. First, we have a bar graph, which is also known as a column graph. This type of graph is a frequency graph for nominal and ordinal data. Notice how the bars don't touch. Bar graphs help you see the shape of the relationship between a discrete predictor and a continuous outcome. They can provide information about the direction, strength, and shape of the relationship if the predictor is ordinal, interval, or ratio. Next, we have histograms. A histogram is a frequency graph for interval or ratio data. A histogram looks almost the same as a bar graph, except here the bars do touch. This is because the data is continuous, and we show this through the continuity of the bars. Next, we have scatter plots. Scatter plots allow you to see the relationship between two continuous variables and provide important information about the direction, strength, and shape of the relationship. The y-axis of a scatter plot represents the outcome variable, while the x-axis represents the predictor variable or variables. The line that is plotted on the scatter plot is known as the line of best fit. Now onto line graphs. Line graphs are not used as often as the other graphs covered, but they still offer useful information. Line graphs provide the same information as bar graphs and are often used when the x-axis represents time or age. Okay. At this point, we are going to switch it up a little and talk more about scatter plots and regression models. Graphs are not only useful in telling us important information about our data, but also if our model is a good fit or not. In order to continue using a model, there are a few assumptions that must be met. First is linearity. We need to check to make sure that the overall relationship between the two or more variables is linear. We can do this by plotting a scatter plot and visually checking the strength of the relationship. Next is having a zero mean. We want the residuals to be distributed around a mean of 0, indicating that our data is normally distributed, with equal values above and below a line equal to 0. This can be checked with a residual plot. Then we have constant variance. Constant variance can also be checked using a residual plot and refers to the variability in errors is the same for all values of the predictor variable. In other words, the distance between the observed value and predicted value is basically the same for all values of the predictor variable. Finally, we have independence. We must be able to assume that the errors are independent from one another, meaning there is no collinearity. These are the 4 assumptions that must be met, But if we are interested in using the model to make formal inferences, the following two assumptions are also needed. First, we must assume that a random process was used to obtain the data, and second, we must assume the random errors follow a normal distribution. This can be checked using a normal quantile-quantile plot, or more commonly known as the QQ plot. We can determine if our data is normally distributed by looking at the distribution of the data points on the straight line. If the majority of our data points fall along the straight line, we can assume that our data is normally distributed. We cannot tell from examining the data whether the conditions for independence and randomness have been satisfied. However, based on the context of the situation and the way the data was collected, we can make these reasonable assumptions. Finally, I wanted to go over a residuals versus leverage graph with Cook's D. Cook's D is a computed value which allows us to check if a data point is an outlier or not. If we look at this graph, we can see a red dashed line in the upper right-hand corner. This line is known as Cook's D, and any value that is plotted past this line is considered an outlier. Alright, that's it for this video. Thank you for watching. If you have any comments, questions, or would like a specific topic covered, be sure to comment down below. Also, be sure to check out my tutoring link in the description if you would like to learn more about statistics and data science or would like to book a tutoring session. Thanks again. Bye!